A school is raising money for sports equipment. They have found that if they raise the price of each candy bar sold, they will make more money per candy bar, but will sell fewer bars in all. The profit P of n in dollars from selling candy bars, where n is the number of times the price is raised by $0.25 from the original price of $0.75, can be estimated with the model P of n is equal to negative 400 n squared plus 3,200 n plus 4,800. Find the price range the school should sell the candy bars for in order to make at least $9,600 for the sports program, for the sports equipment. Alright, so we want to make at least $9,600. So I want the profit, I want P of n to be greater than or equal to 9,600. Making the substitution for P of n, that's negative 400 n squared plus 3,200 n plus 4,800 is greater than or equal to 9,600. Now I'm going to treat this inequality as an equation to find the solutions of the equation, and then I will test on the number line like I've done for similar quadratic inequalities. Alright, so let me rewrite this as an equation. Is equal to 9,600. I will subtract the 9,600, yielding negative 400 n squared plus 3,200 n minus 4,800 equals 0. Now it looks like we have a common factor of 400. I'm going to factor out a negative 400. So I have negative 400 by n squared minus 8n plus 12 is equal to 0. So I have negative 400 by, and this factors as n minus 2 by n minus 6 is equal to 0. So then negative 400 can't equal 0. N minus 2 equals 0 implies that n equals 2. N minus 6 equals 0 implies that n equals 6. So we have two values that solve the equation. So let me set up my number line with n equal to 2 and n equal to 6. And let's test the three regions. Now I'm going to test into this form where now it's equal to 0. Alright, so that's equivalent. So now we want this to be greater than or equal to 0 because our original inequality was a greater than or equal to 9,600, and all I did was subtract the 9,600, so that's equivalent to saying negative 400 n squared plus 3,200 n minus 4,800 is greater than or equal to 0. And I just now have the factored form. That's easier to work with if we're comparing to 0, because now all we have to do is determine is it positive or negative. So let me test n equals 0. If n equals 0, I would have negative 400 times 0 minus 2 times 0 minus 6, which is a negative times a negative times a negative. So this region comes back negative. Now testing in between n equals 2 and n equals 6, let's test n equals 4. I'd have negative 400 by 4 minus 2 by 4 minus 6, which is a negative times a positive times a negative. And that result is positive. And finally, testing a number greater than 6, how about n equals 10? I would have negative 400 by 10 minus 2 by 10 minus 6, negative times a positive, which is a negative. So here's what I see from this. negative 400 times n minus 2 times n minus 6 is greater than or equal to 0 on this interval from n equals 2 to n equals 6. And so that's equivalent to then having the profit greater than 9,600. All right, so here's a conclusion. Now, what this tells me is the profit is at least $9,600 when n is between 2 and 6. But our question asks us to find the price range. So now n was the number of times the price is raised by $0.25 from the original price of $0.75. All right, so if n equals 2, then we would have 0.75 plus 2 times 0.25, and so that would give us a price. That's 75 cents and 50 cents. That would be $1.25. If n equals 6, then we'd have the original price, 0.75, plus 6 times 0.25. So that's $1.75 plus 6 times 0.25 is $1.50. 75 cents and $1.50 is a new price of $2.25. All right, so here is my full conclusion. If the price per bar is between $1.25 and $2.25, inclusive, meaning we can include the endpoints, then the profit will be at least $9,600.